Alright, so this video we're going to look at Chebyshev's theorem. And the theorem says for a set of data, either population or sample, and for any constant k greater than 1, the proportion of the data that lie within k standard deviations on either side of the mean is at least 1 minus 1 over k squared. Okay, so what it's doing is Chebyshev's theorem is telling us the percentage of data that lie within 2 standard deviations of the mean, 3 standard deviations of the mean. Okay, that's what K is. K is the number of standard deviations about the mean. All right, and here's some results from Chebyshev's theorem. And you can memorize these. If you don't, that's fine. I'm going to show you how you can figure this out. It says at least 75% of the data fall in the interval from mu minus 2 sigma to mu plus 2 sigma. So basically what that is at least 75% of the data fall within 2 standard deviations of the mean. And this one says that 88.9% of the data fall within 3 standard deviations of the mean. And this one says at least 93.8% of the data fall in the interval from mu minus 4 sigma to mu plus 4 sigma, or fall within 4 standard deviations of the mean. So, if you don't remember this, that's fine. Let's say we want to know the percentage of data that falls within 2 standard deviations of the mean. So if that's the case, then we know that K is equal to 2. Okay, 2 standard deviations about the mean. So the percentage would be 1 minus 1 over 2 squared. We plug the 2, the number of standard deviations, in for K, and so that would give us 1 minus 1/4, which is 3/4, which that's 0.75. And then if we convert this to a percentage, that's 75%. And there's your 75%. And the same thing would work for 3 standard deviations. We would just plug 3 in. The same thing for 4 standard deviations. We would just plug 4 in for K. All right, so I've got about 5 examples to work, and they're all different. So it's just about everything you'll come across a problem dealing with Chebyshev's theorem. Alright, so here's example 1. It says consider sample data with mean 29.1 and S equals 1.75. Compute a 75% Chebyshev interval around the sample mean. Okay, well, we know a 75% Chebyshev interval, that's 2 standard deviations about the mean. We see that here. See, the 75% is 2 standard deviations about the mean. And like I said, if you memorize it, it's fine. If you don't, that's fine. If you don't memorize it, well, you can just set it up 1 minus 1 over k squared. That's equal to 0.75. Okay, so now we have now all we have to do is solve for k. So here, if I multiply each term by k squared, that gives me k squared minus 1 equals 0.75 k squared. Subtract k squared to both sides, I get negative 1 equals, and that's going to be negative 0.25 k squared. And so I divide everything by negative 0.25. Okay, so that's going to give me k squared is equal to, and that's going to be negative 1 over 0.25. So when we do that, that equals 4. And so k is equal to, if we use the square root property, we know that's 2, or k equals negative 2. Well, we know it's the positive one. We're talking about standard deviations. And so now you can see what k K is. Okay, so that's one way to do it if you don't memorize it. It might be easier to memorize than, going through all this to figure out what K is. Okay, but whatever percentage they give you, you just set 1 minus 1 over K squared equal to that percentage in decimal form, and then just solve for K squared. I'm sorry, just solve for K, and that'll tell you the number of standard deviations. All right, so let's go ahead and find the interval. So if you remember from over here, it tells us the 75% is the mean minus 2 sigma to the mean plus 2 sigma. So it's the mean minus 2 times the standard deviation to mu plus 2 times the standard deviation. All right. So here we have x bar and s, and remember it works for a sample or a population. So we have x bar minus 2s. See, we've got s. Remember, mu is population mean, x bar is sample mean, and sigma is population standard deviation, and s is sample standard deviation. All right, and that's 2x bar plus 2s. So we just plug these in. So that's going to be 29.1 minus 2 times 1.7 to 29.1 plus 2 times 1.7. And then we'll have to punch this into our calculator. 29.1 minus 2 times 1.7, and that gives us 25.72, and then 29.1 plus 2 times 1.7 to 32.5. And so, I guess you could leave it like this, or you can write it as an interval, 25.7 to 32.5. And that's your 75% Chebyshev interval around the sample mean. All right, let's look at the next one. Consider population data with mu equals 20 and sigma equals 2. Compute an 88.9% Chebyshev interval around the population mean. All right, so 88.9, you can see there, that's 3 standard deviations. Okay, and like I said, like I showed you on the first problem, if you need to, you can always solve for K. You could set 0.889 equal to this and solve for K. All right, so let's go ahead and get this. So we know here that K is equal to 3. That's 3 standard deviations about the mean. We just saw that on the other page. All right, so we've got mu minus 3 sigma. See, we're dealing with the population mean and population standard deviation, to mu plus 3 sigma, and now we just plug this in. So that's going to be 20 minus 3 times 2 to 20 plus 3 times 2. And so that's 20 minus 6, that's going to be 14, to 20 plus 6, that's 26. And once again, if you wanted to, you can put it in interval notation, or I guess you could leave it like this. So basically, what is this saying? We didn't really talk about it in the other problem, but this is saying that 88.9% of the data lie between 14 and 26. Okay, that's what it's telling us. All right, so let's look at this one. We have a set of data with a mean of 280 and standard deviation of 65. What do we know about the percentage of data within 2 standard deviations of the mean? What do we know about the percentage of data within 3 standard deviations of the mean? All right, well, let's just take the first one, 2 standard deviations of the mean. So what do we know about that percentage? Well, remember, the 2 standard deviations, we can go back and look at this and know that 2 standard deviations, that's 75% of the data fall within 2 standard deviations of the mean. And like I said, if we forget that, here for 2 standard deviations, we know k is equal to 2. So that means 1 minus 1 over 2 squared is equal to 1 minus 1/4, which is 3/4, which equals 0.75, which that is 75%. Okay, so we know 75% of the data fall within 2 standard deviations of the mean. Okay, all right, well, what is that? Well, let's look. All right, the mean is 280. Okay, 280 is the mean. Well, if we go over one standard deviation, okay, if we go over one standard deviation, that is going to be, let me make this a little shorter. Okay, if we go over one standard deviation, that would be to 345. See, one standard deviation is 65 because that's what our standard deviation is. And then if I go over another standard deviation, that is 410. That's another standard deviation. That's 65. So what did I do? I went over 2 standard deviations. That's to 410. And then I can come back the other way, 1 standard deviation and 1 more standard deviation. Okay, so this number would be 280 minus 65. That's 215. And then subtract 65 again. That would be 150. So this right here is 2 standard deviations above the mean, and this is 2 standard deviations below the mean. So what can we say about the data? We can say that 75% of the data lie between 150 and 410. Okay. All right, so that's what we can say about the 2 standard deviations. All right, well, let's look at 3 standard deviations. What can we say about that? Well, we can say what percentage of the data lie within 3 standard deviations of the mean. Well, we could go back to that table and look, or we can say, okay, k is 3. So 1 minus 1 over 3 squared is equal to 1 minus 1/9, which that is equal to 8/9. And when you punch that into your calculator, that gives you 0.888889. So if we round it to 3 decimals, 0.889, okay, that's 88.9%. So we can say that 88.9% lie within 3 standard deviations of the mean. So once again, if we have our number line 280, and I'm going to add 65, that's 1 standard deviation, add 65 again, that's another standard deviation, and 65 again, that would be my 3 standard deviations. And then I would do the same thing, subtract 65 3 times. Okay, that would be my 3 standard deviations below the mean. So if I do 280 and add 65 3 times, that would give me 475. And then if I do the 280 and subtract 65 3 times, that would give me 85. Okay, so I'm not going to write it out like I did earlier, but I can say that 88.9% of the data lie between 85 and 475. Okay. Alright, so let's take a look at the last two examples. I know this video is kind of long, but we're hitting everything that you will come across, or at least that I can think of. Alright, so here we have math test scores from a statistics class has a mean of 86 and standard deviation of 3. What percentage of the test scores are between 80 and 92? Alright, well, let's draw this out. Alright, so I've got 86, and I want to know what percentage of the test scores are between 80 and 92. Alright, well, my standard deviation is 3. Okay, my standard deviation is 3. So, look at this. If I go over 3 units, that gets me to 89. Okay, but remember, I want to know between 80 and 92. But if I go over 3, that gets me to 89, and then if I go over 3 more, that gets me to 92. And then if I go this way 3, that gets me to 83. Let me write it up here. That gets me to 83. That's 3 standard deviations. And then if I go 3 more, that gets me to 80. So, look at this. I'm what? 2 standard deviations above the mean and 2 standard deviations below the mean. See? Look at this. 1, 2 standard deviations. 1 standard deviation, 2 standard deviations. So from this, I can see that K is equal to 2. That's 2 standard deviations about the mean. That's what the problem's asking, between 80 and 92. So what percentage of data? Well, if you remember the stuff from the first page, then you wouldn't need to do this, but if we do 1 minus K squared, which is 1 minus 1 over 2 squared, that's 1 minus 1/4, which is 3/4, which equals 0.75. So we would say 75% of the data, or 75% of the test scores, are between 80 and 92. Okay. Alright, so let's look at the last problem. Alright, math test scores from a statistics class has a mean of 86 and standard deviation of 4. What percentage of the test scores are less than 74 and greater than 98? Alright, well, let's take a look at this. Let's draw out what we're looking for. So the mean is 86, okay, and I've got 74 and I've got 98. So let's see. I'm going to have to add 4. That gets me to 90. Add 4 again. That gets me to 94. And add 4 again. That gets me to 98. And then same thing on this side. Subtract 4. That gets me to 82. Subtract 4 again. That gets me to 78. Subtract 4 again. That gets me to 74. So what are we here? This is what? 1, 2, 3 standard deviations about the mean. Okay? That's 3 standard deviations about the mean. Okay? So, now watch this. You need to watch this until the end, because it's a little bit different at the end. So that's telling me that K is 3. Okay? So I've got K is equal to 3. So that's 1 minus 1 over K squared is equal to 1 minus 1 over 3 squared, which is 1 minus 1 over 9, which is 8 over 9, which you punch that in your calculator, you get 0.889. That's rounded to 3 decimal places. So that's 88.9. Okay. Now, this is what you need to pay attention to. That is the percentage between 74 and 98. 88.9% of the data is between 74 and 98. But what do we want to know? We want to know the percentage less than 74 and greater than 98. Okay? That's what we're looking for. We're looking for this part out here. Well, if this is 88.9%, then this out here would be what? Well, that would be 100% minus the 88.9%. Because isn't there 100% of the data? Well, if 88.9% is in here, then 100 minus that is out here. So we've got 100 minus 88.9, and so that means that 11.1% of the data is less than 74 and greater than 98. All right, so if you stuck it out to the end, I appreciate it. I hope the video helped. Give me a like, subscribe, share, and thanks for watching.